This will be day 12 notes on evaluating and solving radical equations. So first we have 3 warm-up questions that ask us to evaluate. So we're used to using function notation where it says f of something. And I hope that when you read something like this where it says f of 2, we're realizing that that is a value for x that we would plug in. The new piece of this is actually to evaluate using a square root, which some of us may have seen in 9th grade, but just in case, we're going to pretend like we haven't and do it step by step. So in number 1, it does say f of 2. So I'm going to write a note for myself, f of 2 equals, and then I'm going to use this as a guide. Wherever I see x, I'm writing 2 in parentheses. So that will be 3 times the square root of 5 times 2 minus 6. I'll put a line down my equal sign so it all stays lined up. And now we are literally going to use our skills to evaluate. So 3 will stay on the outside. I need to take care of 5 times 2, which is 10, minus 6 is 4. So if you're comfortable just writing 4, go ahead and do that. If you know that for you it helps to actually write out 10 minus 6 first, do that. Both are right. Either way, you will get to 3 times the square root of 4. We all know that the square root of 4 is 2, so this becomes 3 times 2, which is 6. And we're done. For number 2, the process doesn't change. Lines on our equal sign. Now we are evaluating g of negative 3. Again, this is read g of negative 3. So we know that our new input will be negative 3 wherever we see x. So the negative sign will stay out front. Square root 64 minus 8 times negative 3 minus 7. Notice I'm really careful to make sure that that minus 7 doesn't look by accident like it's underneath the radical sign. So if you haven't gotten your calculators out yet, go ahead and press pause and get your calculators. In your calculators, please do 64 minus 8 times negative 3. If you are still listening, I assume that you stopped the video to go get your calculator. And when you plugged in 64 minus 8 times negative 3, you found that that is 88. So this becomes negative times the square root of 88 minus 7, where that negative really represents a negative 1. Now, the square root of 88 is not a perfect square, but it doesn't mean we don't have an answer. So right now in your calculators, please type in negative square root of 88 minus 7 and see what you get. Let's round to 3 decimal places. Negative negative 16.381. Put it in a box, and we know we're all done. Number 3, we have g of x equals the third root of 8x minus 8 plus 4. We are evaluating g of negative 5. So I put a line down my equal sign. G of negative 5. The process never changes, so I'm very carefully going to use the equation as a guide. And wherever I see x, I will plug in negative 5. I'll substitute in negative 5 using parentheses. Again, being very careful to make sure that that plus 4 doesn't end up under the radical by accident. Eight times negative 5 is a negative 40. Minus 8 is a negative 48. So I have the third root of negative 48 plus 4. Now, when we have a negative under the radical, that's a red flag. It's not an automatic no solution because there's a difference between taking an even root of a negative and an odd root of a negative. This is an odd root. odd roots of negatives, those are okay. So we will use our calculators to get this answer rounded to 3 decimal places. As a reminder, I'm going to put this in green. In your calculator, we want to put in negative 48. And my question to you is, the third root is the same as raising this to what power? I hope we are all thinking or saying out loud to ourselves, 1/3, and then plus 4. So this will be negative 48, and then use that little caret symbol, 1/3 in parentheses, plus 4. We get as an answer 0.3657, which rounds to 0.366. Put it in a box, and we know we're done. That's as much as we need for notes on evaluating, because we already have the ability to substitute in values. We're used to doing that. The slightly new piece is incorporating our knowledge of radicals. Moving on to solving root functions. Let's get into our steps. This is a process that you can constantly reference as you are working. To solve root functions, step 1, if needed, isolate a radical on one side. If needed, isolate a radical on one side. Second, raise both sides to the nth power. And you'll see what that looks like once we actually try one. But for right now, let's just write it down. Raise both sides to the nth power. Step 3, solve the resulting equation. Our last step will be a check. Check the proposed solution, or solutions, because sometimes we might have more than one, in the original equation. This note is relevant to step 4. Note on even roots. Because even root functions, and we're going to use FNS as an abbreviation for function, because even root functions have domain restrictions. We have to check to make sure the answer isn't false. So that's prior knowledge. We all know we can't take the even root of a negative. So when we get an answer, it's not a for sure answer until we've actually checked to make sure that that answer doesn't get us a negative under the even root sign. That's as much of written notes as we're taking on this new skill. The rest will be practice. So let's get right into number 1. We're going to draw a line down our equal sign, and we're going to use our steps each time. So step 1 said, if needed, isolate a radical on one side. Isolate means get it by itself. When I look at number 1, this radical is already by itself, so I don't have to concern myself with getting it by itself. Step 2 is where our work is going to start. It says, raise both sides to the nth power. So my question first is, what kind of root is this? Square root. So think to yourself, what's the opposite of a square root? Raising to what power? So visualize, square root means something to the 1/2. Ask yourself, what would you have to multiply 1/2 by for this to become a 1? Well, the reciprocal of 1/2 is 2. 2 times 1/2 would cancel out. So that is why for here, when it says raise both sides to the nth power, what would undo a square root is raising both sides to the second power. If I raise the left side to the second power, I need to raise the right side to the second power. The square root and the square cancel each other out because what you're really doing is what we took notes on right here. Square root is the same thing as raising something to the 1/2. 1/2 times 2, that equals 1. So the resulting equation here will be 2x plus 3 equals, what is 5 squared? 25. And I asked that without saying it because sometimes we still, by accident, think 5 times 2. So if that happens to you, that's okay. But use that as a learning moment to remind yourself that 5 squared is 25. Because you could have done this correctly, but if you write 10 here by accident, the rest of it's going to come out wrong. Step 3 says to solve the resulting equation. This is a 2-step equation, so please press pause right now and go ahead and solve. To solve, I will subtract 3 from both sides. We get 2x equals 22. Last step, divide by 2, divide by 2, x equals 11. We are not done though because it says right here, as a reminder, we have to check. Whenever we have an even root, this may or may not be the answer. So the blank space to the left of each question has been put there for a reason. It's where you're going to show your work for the check. So to check, we're going to substitute 11 back into our original equation. So that's going to be the square root of 2 times 11 plus 3 equals 5. Remember, the goal of a check is that left side equals right side. So on the left side, I have square root. 2 times 11 is 22 plus 3. And then on the right side, I still have 5. 22 plus 3 under the radical now becomes 25 equals 5. Notice I'm just bringing down the equals 5 each time. Square root of 25 is 5. 5 equals 5. Check. Now we are done. We had a potential answer, and we just confirmed that it is a real answer. When we look at number 2, what's different about number 2? Yeah, instead of a square root, we have a third root. So the question is, 1, it says if needed, isolate the radical on one side. Well, the radical is already by itself. So now we go to raise both sides to the nth power. What is the appropriate choice of power here? the opposite of the third root is raising to the, when I say third root, we're saying a power of 1/3. So let me be clear with that. Third root meaning 1/3. The opposite of raising something to the 1/3 would be raising it to the 3 divided by 1, or just 3. So we are going to cube both sides. If it helps you, you could actually gently cross out that 3 with that cube root. The cube root and the power of 3 cancel each other out, leaving behind 3x plus 4 on the left side equals 3 to the third, which is 27. And from here, we just need to finish solving. So to solve, what would I do first? We will subtract 4 from both sides. That gets us 3x equals 23. Divide both sides by 3. We will get a decimal answer. So using your calculator, please find 23 divided by 3. Round into 3 decimal places. 7.66, and it keeps going, so we'll round it to 667. Now the question is, do we need to check this answer? Remember, back here, the domain restrictions only exist for even root functions. So the question is number 2 an even root? No, it is not. So make yourself a note. Odd root, no domain restriction, because you can take the odd root of a negative, so no domain restriction. No check needed. Now, it's a different story if you want to actually substitute in your answer just to check your own work. But in terms of possible domain restrictions, odd roots have none, so no check needed. Number 3 is the first example of where that first step is actually going to come into play. When I look at what I have the fourth root of x minus 3 plus 6 equals 5. So the question is the radical by itself on one side? No, it's not. So we need to isolate the radical. Let's get a line drawn down our equal sign. Drawing that line really helps you to see each side, so I highly recommend it, especially with these solving questions. To isolate the radical, what needs to move? That positive 6, how? And that's exactly what we're going to do. We're going to subtract 6 from both sides. So we get the fourth root of x minus 6 equals 5 minus 6 is negative 1. Now that the radical is by itself, we're ready to keep going as we were. So what would cancel with a fourth root? What power? Oh, I think that's supposed to be a 3. Sorry. X minus 3. Apologies. So back to the question. What would cancel with the fourth root? Raising to the, what power? Fourth power. What is left on the left side? Just x minus 3. And then negative 1 to the fourth, is that a positive 1 or a negative 1? Well, if I think about it, that's 1, 2, 3, 4 negative 1s. That's a positive 1. Positive 1, 1 times 1 is positive. So it's a positive 1. In general, if you can remember this important little math fact, a negative raised to an even power will always be positive. So I have x minus 3 equals 1. To wrap this up, we will add 3 to both sides. And our potential answer is 4. I say potential answer because what kind of root is this? It is even. And if it's even, what do we need to do? We need to check. So write check, and let's check it. Remember, we are going to substitute into the original equation. So that's going to be the fourth root of 4 minus 4. I keep saying that, I'm sorry. 4 minus 3 plus 6 equals 5. Again, notice how careful I am to make sure that that 6 does not get under the root by accident. This right side will stay 5 the whole time. The goal is that the left will come out to equal the right. So let's simplify under the radical. 4 minus 3 is 1, and then plus 6 equals 5. What is the fourth root of 1? 1 plus 6 equals 5, and 1 plus 6 is 7. Did this come out to be true or false? False. Now first, you would always want to make sure you actually didn't make a mistake yourself with your check. So it doesn't hurt to kind of run back through and make sure you didn't make a sign error of any kind. But when I check, I did 4 minus 3 is 1, fourth root of 1 is 1, 1 plus 6, that's 7. So this is false, which means I will cross this out. Don't scribble it out. Just cross it off. And what two words will we write? No solution. So our potential answer proved false, which means we have no solution. Pause the video, please, and try number 4 on your own. I will come back to check your work with you. Please get as far as solving for x, and then rejoin me on the video to check if our answers match. Let's check answers. So first I need to isolate my radical. So I will subtract 8 from both sides. So I get 2 square root of x minus 1 equals negative 6. Now the question is the radical all the way by itself yet? The answer is no, because of this 2 up front. So this is 2 times the radical. What would undo that multiplication? The inverse of multiplying is dividing. So to finish getting it by itself, we need to divide both sides by 2. So these 2's are gone, because 2 divided by 2 is 1. We get the square root of x minus 1 equals negative 3. Now the radical is completely by itself. Now we can tackle the square root. What is the opposite of taking the square roots? Raising to what power? So recall, square root means raising to the 1/2. The opposite of 1/2, or excuse me, the reciprocal of 1/2 would be 2. So we will square both sides. Again, if it helps, gently cross out the 2 and the square root. Those are inverse operations, leaving behind x minus 1 equals a positive 9. And then lastly, I will add 1 to both sides and get x equals 10. Now the question is this an answer or is this a tentative answer? Is this a possible answer? When I go back and look to figure that out, I need to ask myself, is this an even root or an odd root? It is an even root because it's a square root, so before I can say this is my answer for sure, off to the side, we need to check. So let's run through the check together. It would be 2 times the square root of 10 minus 1 plus 8 equals 2. Line down your equal sign. Goal is that left will come out to equal right. What do I now have under the radical? What's 10 minus 1? Good, so I get the square root of 9, and then plus 8 equals 2. Square root of 9 is 3, so 2 times 3 plus 8. 2 times 3, 6 plus 8, 6 plus 8, 14 equals 2. Now before we go and say it's false, let's double check. 10 minus 1 is 9. Square root of 9 is 3. No sign errors here. So what do I write here? First, about the check, we write false. We had no other possible solutions to check. The only one we had to check turned out to not work. So the answer here is no solution. So here's two different examples of what it would look like for the check to not work out. And if that's the only answer you had to check, no other answers are possible, no solution. Let's step up our game a little bit and take a look at number 5. These are both titled heavyweight solving. You'll see why in a moment. The steps don't change. So without looking at what you wrote on the previous page, what's the first step? Isolate the radical. So to do that, what needs to move first? This x that's on the outside. So let's take care of that first. We're going to subtract x from both sides. For these two examples, it's really important you have no distractions, because this is going to take some thinking. So I have the square root of 26 minus 11x. Now, 4 minus x, those are not like terms. So I'm going to literally write it just as it says, 4 minus x. I have nothing else that I can do to isolate the radical, so next, let's eliminate the radical. We are going to raise both sides to what power? The second power, very good. So on the left side, the square and the square root cancel, leaving behind 26 minus 11x. This is where our heavyweight comes into play, that heavyweight title. 4 minus x squared really means 4 minus x times 4 minus x. So for right now, on the left side, leave that alone. We're going to use our arrows to distribute. 4 times 4, 16. 4 times negative x, minus 4x. Nowhere else to send arrows in the top. Let's send arrows in from the bottom. Negative x times 4 is negative 4x. And then negative x times negative x. Negative times negative is positive x squared. 26 minus 11x is still on the left side. Let's write standard form right away. So if I'm writing standard form, what would come first? X squared. And then combining like terms, negative 4x minus 4x is negative 8x. And then last but not least, plus 16. We are working with a quadratic, but we have those skills. So to solve quadratics, where I have 3 terms, I need the one side to be equal to 0. So I'm going to target the left side because that's easier to move. We have good solving skills, so I'm comfortable if we do 2 things at once. So I'm going to subtract 26. And I'm going to make sure that I write it under what it is like terms with. So I choose to write minus 26 underneath the 16. I can also add the 11x. And you make a decision. Where does it make sense to write plus 11x on the right side? Underneath the minus 8x. Good. Continue your line down the equal sign. So this is 0, this is 0. So in one step, I get my 0 equals. This is going to be x squared plus 3x minus 10. Our go-to strategy will always be to factor if we can. So is this a is 1 or is this a is not 1? Well, when I look here, it's an invisible 1 out front. So this is a is 1. So as a reminder, when a equals 1, factors of c that add to b. So as a reminder how to factor when a equals 1. So I'm looking for factors of negative 10, that add to 3. And I'm hoping we're thinking 5 and 2. But which of these has to be negative to obtain a positive 3? The 5 will be positive and the 2 will be negative. Because when I multiply 5 times negative 2, I get my negative 10. But when I add, I get a positive 3. So this factors to be, I don't like how I wrote that, so I'm going to rewrite it. What factors will I write? X plus 5, and then x minus 2. To solve, what will my answers be? As a reminder, the reason why factoring helps us out is because there's some value of x that makes the first factor 0. So I could set x plus 5 equals to 0 and solve. What would I get from that? Negative 5. And then I set the second factor equal to 0, and I get x equals positive 2. Do we need to check? Well, when I look, this is an even root, so yes, we need to check both, which is why you have some extra space down here to run a check. So what I'm going to ask you to do is to finish the check on number 5, and then number 6 I'm leaving as a you try, and I'm asking that you try this tonight before you come into class tomorrow, because we will start tomorrow's class checking your work against mine for number 6. Any questions on the check for 5 or number 6, please send a message on Remind. Nice job. Tomorrow's classwork will start right here with the independent practice and homework right there. So again, to wrap up your work tonight, please finish the check, and then you are working on number 6 on your own. Good job.